Okay. The path of the rocket is given by the equation. Its graph shows the height h in feet of a small rocket t seconds after it is launched. Given h, that's the height with reference to the time, so h of t is equal to negative 16t square plus 192t. So we have to find we have to first draw the graph of the rocket on a separate sheet of paper and make sure to identify your zeros, maximum or minimum, one of those will be, and x and y intercepts we have to find. X intercept is gone. So at what time does the rocket reach the maximum height, and all other details, further information we have to find, like this: what is the maximum height, what time it reached, about how high is the rocket after 1 second, is there another time it reaches the same height, and so many things like that. Okay, that they're there in the next page. Also you have some questions. Is there another time that reaches, and then what is the, at what time will the height is going to be 350 feet, and give the domain and range of the function with reference to this context, increasing interval, decreasing interval, and two more questions, like what is the average rate of change from 3 to 4 seconds, and during what interval of time does the rocket travel at a greatest rate. So those are the things we have to answer. So in order to answer that, I'll just show you using this Desmos graphic calculator. Okay, here we have this Desmos online graphic calculator, and I'll go ahead and type in my h of t is equal to negative 16 square plus negative 16, then t square plus 192t. So this is the function you got. H of t is equal to so and so. What is that? Negative 16t square plus 192t. So what we'll do is, the graph is not at all looking a friendly kind of thing, just a single straight line, this red line you see on the y-axis. So the best thing for you is to just go to the this edit list and then convert it to a table. So you have a table here, and after getting this table, we will we need only the positive values, and I just highlighted the 2 and press enter, and these are the timings on my first column, and in the second column you are having this height with reference to the timing. Okay, so in 0 seconds it started off with the 0 was the initial height. 1 second it reached to a height of 176. 2 seconds 320, and like I said before, highlight this and then hit enter, you got in 3 seconds the height reached is 432, etc. You can go all the way up to till you get a 0 on this second column, that is the height is becoming 0. So what happened actually, the rocket, it left the ground from 0. This is the 0. From 0 it left, went up all the way high into the air, and again came back to ground in 12 seconds. That is the whole story. And this values, the time on in this first column and the height in the second column, are giving you the information about the minimum and maximum values. So with reference to these table values, I'll go to the settings and fix up my settings so that you're going to get a better graph here. So let us see my x values. I'll start up with like 0, 0 is very much like it covers the whole thing. That's why little extra value will take. I prefer to use negative 2 and delete the other things. This is negative 2. I'll get negative 2 here. Minimum, max, that is up to 12 seconds it is going. So let me take How much? 14, right. Let us type in 14 seconds with the steps of 1. So we took care of the time. And now what is the height? Here you are seeing that the maximum height reached is see between 560 and 560 over here. You can see 576 is the maximum height reached. So we need to go at least up to 600 on the positive y-axis. So let me fix up my settings. Here at least 600, right? So 600, then negative also I need some negative so that I can see the whole of the x-axis can be seen clearly. And with the steps of 50 I'll go, right? So look at the settings here. X, we have -2 to +14 with the steps of 1, and on the y-axis -50 and all the way up to 600 with the steps of 50 you got. Now see the graph. You can see one neat graph here, right? This is the graph. Okay, and all the values are also there, like in 1 second this is started off at 0, right? In 0 seconds the height is 0. In 1 second it 176. 2 seconds, 3 seconds, this is the height. 4, 5, 6, then 7 is up here. Yeah, 560. 8, 9, 10. Everything you can answer now. What all questions that you have seen a minute ago in the first slide, everything can be answered. What is the maximum height they asked? So maximum height reached is 576. What are the zeros? Zeros are the x-intercepts. These are the two, 0, 0, 12, 0. Those are your x-intercepts. And in 1 second, what is the height reached? It reached 176. And again, at what time it is going to come back to 176? So it goes up and again comes down. In 11 seconds it reaches 176. So all that information you can write over here. This you got. What are the zeros? You got 0, 0 and 12, 0. Those are the two zeros. Maximum height 576. At what time does the rocket reach maximum height? You saw that in 6 seconds. And then what do you have next question? What is the maximum height of the rocket? Again it is repeated. This is what 576. In 1 second it reached 176 feet. Is there any other time? Yes, you have seen in 11th second, right? In 11 seconds it reaches 176 again. And next slide here. Is there any other time? Yeah, that's covered there in the previous slide. At approximately what time is the rocket 350 feet height? This is little tricky. Let me show you. 350 is the height. You are looking for height. 350. Go to your second column. Do you see 350 anywhere here? I can see 320 and then 432. So 350 is between 2 and 3 seconds. In between this time, somewhere around. And it is little closer to 2 seconds only because 320 is there and that is 432. So to get the exact time, this utility Desmos is so useful to find that exact time at which the height is going to 350. I'll just type in y is equal to 350. 350. Now you see there y is 350. Here you have 350. And what is the time it is saying? 2.242 seconds. So in 2.2 seconds it reaches a height of 350, like we just guessed in a minute ago. 320 in 2 seconds. So 350 will be 2.2 seconds. And again it reaches to that 350 after going high and coming back. That is after 9.6 9.758. That you can call it, say it as, rounding it to the nearest tenth, it is 9.8. So I'll write my answer as 2.2 seconds and again 9.8 seconds. Okay, so this is 2.2 seconds or 9.8 seconds again. Then you got give the domain and range of this rocket function in this context. You see, it is a rocket and it is the time and the height. So the time and the height cannot be negative numbers. We need only the positive values. So therefore, my domain, we started from where the time started from 0 seconds and again it came back to the ground. The rocket reached the ground in 12 seconds. So the whole story ended in this 12 seconds. That's why we write our domain is 0, 12. And what is the range? Range is the y value. So you'll start from 0, go all the way up to 576 feet. 576 feet. That was the highest point it reached. So that is the domain and range. Please do not write the domain and range from this settings. This is only for our convenience to have a better graph. We did this. Don't go by these numbers, but go by the numbers from the table, from this chart of this time and the height. Okay, so you got that. On what interval of the domain is the function increasing and what interval it is decreasing. So increasing interval you have here from 0 to 0 here, the maximum height reached 576 up to this. And again from 576 it came to 0. So that x is equal to 6 or the time t is equal to 6 is the one that is separating into this increasing and decreasing values. So I have drawn one line there at x is equal to 6. You see. So these are the domain values. So starting from 0 all the way up to 6, we are seeing there is an increase in the y values. See in this table also here, starting from 0 all the way up to 6, there is an increase in the y values. So that's why we say that this is the increasing interval 0 to 6. Only the domain values will have to be considered for the increasing intervals and decreasing intervals. So similarly from 6 seconds to all the way 12 seconds, what happened? They are going down and down, right? So that's what it is. So I'll write here my increasing interval is starting from 0 to 6 and the decreasing interval 6 to 12. Please remember, try to understand this, what is increasing and decreasing, and all this is the domain values only. You are taking the time, that this is the time, that is also time only, and only the y values you are looking at. The height, in this the height was going higher and in the second case the height is going down. That's why he said decreasing. Okay, and now what is the average rate of change? So what is the average rate of change between 3 and 4 seconds? So I'll go back to my table here, chart 3 seconds and 4 seconds, that is here 3rd and 4th seconds. Take those two values. So first one is x1 y1 and other is x2 y2, and we know the formula for average rate of change. So 3 432 and 5 12. 432, 3 comma 432, then 4 comma 5 12. Now the average rate of change is equal to the formula y2 minus y1 over x2 minus x1. Okay, that is 512 minus 432. Let me write 512 minus 432 divide 4 seconds minus 3 seconds. Now 512 minus 432 is how much? 0. 11 minus 3 is 8. So 80. And denominator is 1. That is, it is telling me that from 3 to 4 seconds, during that time, the rate of change of that rocket was 80 feet per second. In 1 second, it is going up at this rate of 80 feet. Okay, that is the thing. Now, this lastly, what is the during what interval of time does the rocket travel at its greatest rate? Here, the interval of time we are considering 1 second to be the time interval. So go by this table again. In 1 second, from 0 to 1 second, the height increased by 176. This much higher it became. Then at 320, right? In 2 seconds, it reached 320. In 3 seconds, 4 seconds, like that. In which time interval is the rate of increase in the height? Whether it is increase or the decrease? They're just looking for the greatest change. Okay, so we have to look for that, and it is obviously in the starting first second and in the last second. You see so much gap, and you will also see. So this is how you can say that during the first second and the last second, from 11 to 12 seconds, the rate of change is the maximum, because the height from 0, it went all the way up to 176, and from 11 to 12 seconds, from 176 it is reaching 0 all the way down, right? So that's what happened here in this graph. Okay, so that's how we can answer the last question. Okay, and thanks for watching, and this should clear all your confusion.